So we are going to discuss and solve the homogeneous differential equations. So solving the homogeneous differential equations, it must be in the same degree. And by putting it in the form of m times x and y dx plus n times x and y dy is equals to 0, which is our simpler, you can solve it by the substitution using the equation y is equals to vx and dy is equals to x dv plus v dx. Following the changes of variables, you can integrate the differential equation by the separation of variables. So for our example number 1, 2x dy is equals to x plus y dx. So as you can see, it is already in a first term, and its simpler is n, so we let y is equals to vx, and then the derivation of dy is equals to the derivation of v dv times x plus v, then the derivation of x, which is dx, and then substitute them, and it will become dy equals dx dv plus dv dx. So we'll just to put them in their order as 2x times x v dv plus v dx is equals to our x and our y is equals to x vx, and then dx. So as we can see here, we can factor out the x. In which will become x plus 1, since it has a constant 1, plus v, then dx, and then using the distribution, we will, as we can see, we can cancel the x and then substitute, distribute them. So this will become 2x v dv plus 2v dx is equals to 1 times dx is equals to dx plus v dx. So now we will subtract them with v dx. As we can see, it has a common, so subtract v dx to v dx. So this will be cancelled, and obviously the v dx has the constant of here 1, so it will become just simply v dx is equals to dx. So now we will transpose it here, and this will be transposed here, so it will become 2xv dv is equals to
dx minus, since we transfer it, it will become negative. And then we can factor their x here. So this will become v dv is equals to, we will factor their dx, sorry. So it will remain 1 minus v, then dx. So as you can see here, we can use the separable variable. When we will then we will divide them both sides by 2x times 1 minus v. So this will be cancelled and the 2x will be cancelled, so it will have as v dv over 1 minus v is equals to dx equals to 2x, or we can simply say 1 over 1 minus v dv is equals to 1 over 2x dx. So now, as you can see, we can integrate them. So the integral of 1 over 1 minus v dv equals to 1/2, because we bring the 1/2 to the in front of the integral, then the integral of 1 over x dx. So now we can integrate them. So the integral of 1 over 1 minus v is simply the negative of ln 1 minus v, then equals the integral of 1 over x is just simply ln x. Then plus the c constant. So as we can see here, it has a natural base logarithm, and we will transfer it here. So this will becomes ln 1 minus v to here negative 1 is equals to, so 1/2 ln x is just simply ln x raised to the 1/2 plus the ln ln and then we will transfer, this will becomes ln times 1 over 1 v is equals to, so this will becomes ln to the square root of x plus ln sorry, because it has the condense of two logarithms which will becomes into a single logarithm. So as of this, ln A plus B ln B is equals to ln times AB. So we all know that the ln 1/1 V minus V is equals to simply D. Here A is C and B is square root of X, so this will becomes C then the square root of X. Kita. And then we can set the inside of the natural log of the expression inside equal to each other. So this will becomes 1 since we can set them inside. So 1/minus V is equals to C square root of X. So we know that Y is equals to Vx, and then V now is Y over X. So we replace it. So this will becomes 1/1, then minus, since our V is negative, Y over X is equals to C then the square root of X. Now to simplify this complex fraction, we will multiply them by both sides. So this will become X, and this will then here become X, then this will be cancelled. So we've left with X over Xn minus Y is equals to C with the square root of X. So as you can see now, we will eliminate the X minus Y. So to do that, we multiply them both sides. So this will cancel. So we have X is equals to C the square root of X, and then times X minus Y. So now we will cancel the square root of X. To do that, we'll just multiply them by exponent of 2 both sides. So this will be cancelled, and we distribute, then this will be cancelled. So we left with X squared minus C squared, C squared X, since we cancel the square root, then X minus Y squared. So now we will divide them both sides with X now. Our general solution. So this will be cancelled, and this. So it left us with X equals to C times X and X minus Y squared. So as c squared is constant, we can derive it as c. So our final answer is, it will become the absolute value of absolute is equals to c times x minus y squared, and this is our general solution. So for our example number 1, y prime is equals to xy over x squared minus y squared. So we know that y prime is dy dx, so we just simply write it, and we cross multiply it, so it will become xy dx is equals to x squared minus y squared dy. So as you can see, it is an ensemble layer, so we let y is equals to vx, and then dy is equals to x dv plus v dx. So now we just plug in all of the equations, as y is equals to vx and dy is equals to x dv n plus v dx. So it is right here. Now we will distribute them by ordering here. So this will become v x squared dx is equals to x squared minus v is so now, as you can see, we can factor this x. I mean, this will be, yeah, we will be factoring that out. So v dx is equals to x squared times 1, since its constant is 1, so times so now, as you can see, we can cancel out the x squared right here. Cancel out. But first we will cancel. So now we can use this FOIL method right here to distribute. So this will become v dx is equals to the distributing factor x dv plus v dx equal negative v squared dv is equals to v dx. I mean, this is gonna be a cube, since right here, I forgot. So now, as you can see, it has a identical term, v dx and v dx, so we cancel that out. And as for v cube dx, we will distribute it right here, so this will become positive v cube dx is equals to x dv minus x squared v squared dv. So now we will factor out the x. So this will becomes, we'll factor out the x right here, then x dv. So now, as we can see, we can use the separable variable. Oops. So as you can see, we will divide them both sides. Oh, naman ako. Sorry. So x will be cancelled and v cube will be cancelled, so it remains as dx over x, or we just simply write as 1 over x dx. Oops. Dx and equals to 1 minus v squared over v cubed dv. So as you can see now, we can now integrate the following, but first we need to separate this into two integrals. So this will become the integration of 1 over negative v cubed dv minus the integral of 1 over v dv. So using the power rule, this will becomes, using the power rule, this will becomes the integral of 2v squared dv minus so now we can integrate them. So this will become ln x is equals to negative 1 over 2 v squared minus ln v plus c, all 1 over the variable is will become ln in integration. So now we recall that y is equals to vx, and now v is equals to y over x. So, and now it will become ln x is equals to negative 1 over 2 times y over x squared, since we replace v into y over x, then minus ln y over x plus c. So now we recall that ln times a equals to ln b. Well, now it is equals to ln a over b. So now it will become ln x equals 1 minus 2 y cube over x cubed, and then minus ln y minus ln x, then plus c. So as you can see, in order to remove the x squared, we need to multiply them by their fractions. So this will be cancelled, and it left us with ln x equals to negative x squared over 2y squared minus ln y plus ln x plus c. Now, as you can see, we can remove the ln x. To do that, we need to divide them both sides. So this will be cancelled, and here and here. So it left us with